Hello, my name is Lauren Denton, and I've been working with Akshay Sutre and Will Watson on designing and optimizing the Chase Bank drive-through experience. So a little background, banks, they typically have one teller, it runs multiple lines, and they only have one ATM that's available to be used. By doing a study on a local bank, we were able to determine if they need additional tellers, if they need less tellers, if they need more ATMs, if the queue times can be reduced by changing any of those, and also if those additional resources might allow for additional customers. The scope of our project includes the number of tellers used to support the drive-through only, a typical workday, and includes the number of ATMs available. Not included in this scope is any high variance in demand for usage at the bank. This often happens at the end of the week, beginning of the month, or during a financial crisis, maybe a rush on the bank. We're not including any of that. Just a typical, we'll say Tuesday through Thursday weekday. So for our model, we have 4 tellers at various times of the day, and we have that scheduled in there. Akshay is going to show that in a little bit here. There's a decision module that's based off of the probability for using the window. The pipe's just a little tube that you put your deposit in, or using the ATM. There's 3 drive-through lanes for the transactions. And in the study, one of the teller pipes will actually be switched to an ATM to remove one of the bank tellers, instead have an ATM, which we believe will be faster and better. So here's just a quick picture of the model, and like I said, Akshay is about to go through that with you. And here's a little bit about the animation. The animation accurately, it just shows the building, the roads. Akshay did a great job with it. He's able to show us how everything is set up at the bank. It was created using routes and stations, and the drawing reflects the actual layout of the bank through the drive-through system. The cars depict the customers as they're driving through the drive-through, and obviously you can speed up or slow down the animation speed as you desire. And now I'm going to turn over to Akshay, and he's going to walk you through the model itself.
Hello everyone, so I'm Akshay Sutrave. I'm going to talk to you guys a little bit about the actual simulation in Arena. So what we had to do was we made 2 very similar simulations, but one which did not have an ATM, and as you can see, the animation is going to be run here. So we started with a create module, and then we assigned a picture to the cars, and then we had a lot of stations to make sure that the route works here as well. For the decision, we used 33, 33, 33 because every single one of these lanes, it's just like going to a teller. There's no automated process involved, except for pipe 1 and pipe 2 will be you putting your deposit inside of a pipe. It zooms up and then it goes to the teller inside, whereas the window is actually just going to a window. So we calculated the different process times here using the input analysis and the data that we collected, and then same thing for the pipes. We did that. So let's go ahead and give it a run. So as you can see here, it's being run through 100 different cycles, and that's so we could do a pan analysis to see our results. So as you can see here, I'll show you for the queue. It has the time. It's very similar for all 3. Now let's take a look at the other one. Now this other one, it's a very similar setup, except for this is going to be an ATM instead of another pipe. And let's go and give that a run and see how that looks. Again, this is going to be run through 100. And then the results here, you can notice a drastic difference in the queue. For the window and the pipe, since more people are inclined to use an ATM, sure, the queue at the ATM is going to be a little bit larger than the pipe and the window. It's still going to be significantly less than what it was before. And Will is going to discuss more on the conclusion and the results that we got as well. And I guess that's about it. Thank you.
Hi, my name is William Watson. I will go through the results of the project. At first, there were a few bugs that caused the output to be less than the realistic average, around 20 to 30 per day. So instead, we reevaluated the data to determine that an exponential arrival system with an average of 2.5 more accurately reflected what we had viewed. This gave an output of 180 customers, which was much closer to the average typical day at the bank. With validated data, we ran the process analyzer to determine that the proper number of ATMs is to add an ATM to the current amount due to a drastic reduction in queue time from 1.98 minutes to 5.4 seconds, virtually removing all of the queue time. We also determined that we should reduce one of the tellers for the optimal queue times through the system. Here is the crystal report from the current system showing that each queue times for pipe 1, 2, and the window, a queue time about 0.03. Here are the results of the proposed system, knocking the queue time down to 0.02 for the ATM, 0.001 for the pipe, and 0.001 also for the window queue. So conclusions and recommendations. Our conclusion is that while there is a cost associated with ATMs and tellers, the customer experience can improve for a low cost by replacing one teller with an ATM. Our recommendation is that one ATM will be ordered and one teller will be removed. This will allow for the optimal flow through the system, allowing for the maximum number of customers to move through the system in the quickest manner at an affordable cost. The cost will break even over time as machine costs less than people do, and they work 24/7, and also they make less mistakes. It is projected that more customers will be able to use the system due to the improvements and higher customer satisfaction as well.